Okay, so today we're going to look at the natural logarithmic function, and we're going to look at the integration. So make sure you have your notes printed out, and we'll get started. And I gave you, in your notes, I gave you the rules, and you had that rule that the integral of 1 over x dx is equal to the natural log of x plus c, and then you had the integral of 1 over u du is equal to the natural log of u plus c. So we're going to do a few examples of that. All right, so when I see one like this, all right, I like to go ahead and pull my 10 on the outside, okay? And then you've got the integral, 10 times the integral of 1 over x dx. And again, you want to just memorize this rule, okay? And we just looked at how to take the derivative, you know, of a natural log, and it's whatever's behind the line on the bottom and the derivative on the top. And so the derivative of natural log of x was 1 over x. So we're going backwards. And you want to memorize that rule that the integral of 1 over x dx is equal to the natural log of the absolute value of x. We can't take the natural log of negative numbers, so we throw those absolute values in there. Plus c. All right. We've looked at u substitution in the past. We talked about when you had a parenthesis to a power or the angle on the trig word, you know, you let those be u. Whenever you're looking at something like this and you've got this, this fraction, one thing you can try is to let u be the whole denominator. And I'm sorry it's not as clear. It should be clear on the notes that you printed out, but when I copied the pictures over, it didn't work so well. But we'll let u be the whole denominator, which is 5 minus x cubed. And then du would be a negative 3x squared. And so when I'm looking, I see that I have that, you know, x squared on the top. All right, so when I do my replacement, all right, I'm going to call the bottom u. So I'm crossing that part off. That's u. And this is just personal preference. A lot of people like to put du over u, and they memorize that rule. But y'all know that this is the exact same as this. I just prefer it written like this. So this is the way I have my rule memorized. But your book, you know, may have said that, but it's the same thing. I like to put the 1 over the u. So I'm going to go ahead and stick my 1 in there. Now I need to get du. All right, well, if I'm looking at it, I have x squared dx, but I need that negative 3x squared dx. So if I multiply in that negative 3, remember we cancel it on the outside with the negative 1/3. So I'm going to bring that negative 1/3 down, and then now I've got negative 3x squared dx. That becomes du. Okay, and so just like before, you want to memorize the integral of 1 over u du is equal to the natural log of the absolute value of u. So this is going to be, bring down that negative 1/3 times the natural log of the absolute value of u plus c. And remember, from u substitution, don't forget to switch it back over to whatever your variable was. We had x before, so 5 minus x cubed plus c. Okay, so one thing you can try is when you have a fraction like this, you let u be the entire denominator. Now, don't want you to confuse b and c. We have done examples like c before, and so I wanted to throw another one in here so you see the difference. Remember, when there is one term on the bottom, we did these back in the first lesson, what you have to do is split it up, divide it out first. So I'm looking at integral of x to the 4th over x cubed minus 5x squared over x cubed. All right, so do your algebra first. So that's just the integral of x minus 5 over x dx. Okay. So I'm going to integrate both of these. Because I've got that 5 over x, I like to think about them separate. I'm going to integrate x, and I'm going to go ahead and pull out that negative 5, and I'm going to integrate 1 over x. Okay, so we normally, you know, when we have a whole bunch of terms, we don't write them separate, but because I had that fraction, that over x right there, I wanted to separate them. So I know how to integrate x. I just add 1 to it, divide by the new power, 1/2 x squared. And then I've got this one now, minus 5 times the natural log of the absolute value of x plus c. Okay, so don't confuse b and c. Make sure when you have one term on the bottom, you do the algebra, you split it up, divide it out, and then integrate it. All right, when I'm looking at this one, I got more than one term on the bottom, so I'm going to try to let u be the entire denominator. X cubed plus 6x squared plus 5. So then du is going to be 3x squared plus 12x. So let's see if I could make that happen. Now, sometimes you can't get it to work out and you have to do a different integration technique. The more we learn, the more different cases that we have. But if I look at this one, if I let that bottom, that denominator be u, and we'll go ahead and throw in my 1, could I get du out of this? All right, well, I have x squared plus 4x, and I need 3x squared plus 12x. I have the right amount of x's, but I need that factor of 3. So if I multiply n by 3 and distribute it, I would have 3x squared plus 12x. So I just need to multiply in that 3, cancel it with the 1/3. So bring down the 1/3, and then that whole top now becomes du. So this is, have it memorized, integral of 1 over u is the natural log of the absolute value of u plus c. So that's 1/3 times the natural log of the absolute value of u, which is x cubed plus 6x squared plus 5 plus c. Okay. All right. Now, you have one like this in your homework, and it says when the degree of the top is greater than or equal to the degree of the bottom, you may, it's not always going to work, but you may want to try long division first. So remember, degree, the highest exponent. On the top, on this one, it's an x cubed. Sorry, it's not so clear. But I've got an x cubed on the top and an x on the bottom. I'm higher on the top. So you are supposed to remember how to do long division, but let me show you real quick. You could do synthetic division or you could do long division. But remember, when you get ready to divide this out, you're supposed to think about your exponents, and everybody needs a place, you know. And so the highest exponent I gave you was 3. So you're supposed to go 3, 2, 1, none. You're supposed to count down and not skip anybody. And we did skip somebody. We skipped the x squared. So remember placeholders. If you skip somebody, you've got to hold their place. And we're dividing by x plus 5. Okay. All right, since we're dividing by a binomial, we're going to start, one spot over, which would line me up 2 terms under 2 terms. And we say, all right, how many times does x go into x cubed? That's going to be x squared. All right, what you're going to do is multiply that back down. So if you need to write it to the side, distribute that through. You get x cubed plus 5x squared. Draw a line, change the signs on the bottom. So this goes negative, this goes negative. Those cancel, and I'm left with 0, 0 minus 5. And I don't know why I wrote a minus there. I always write plus 0. It doesn't matter. 0 doesn't have a sign. But 0 minus 5 is negative 5x squared. Bring down your negative 6x and start back over. All right, so now we're saying how many times would x go into negative 5x squared? Well, it would go negative 5x times. That's what we distribute, negative 5x through there. So we get negative 5x squared, and we get negative 25x. Draw a line, change your signs of the bottom. So that one goes positive, that one goes positive. Those cancel, and what 25 minus 6 is going to be 19x. Bring down your negative 20. Okay, so now start back over one last time. Now we say how many times would x, how many times would x go into 19x, and it goes 19 times. So that's what I'm going to multiply. So distribute that 19, and I get 19x plus, I don't know, what is 19 times 5? 95. Draw a line, change your signs on the bottom, and I get negative 115. So that's my remainder, so minus 115 over x plus 5. All right, so now I've got the long division out, so now we're going to rewrite what we have. So remember, my original problem was to integrate this. All right, so I did the long division out, so now my problem becomes integral of, it was x squared minus 5x plus 19 minus 115 over x plus 5 dx. Okay, so I'm going to think about this kind of in 2 separate problems. I know I've got to integrate these. These are all just basic power rules. And then I'm going to pull out the 115, and I've got the integral of 1 over x plus 5. So I'm going to think about them as two separate ones because these first three are just power rules. We know how to do it. You know, you add 1 to it, divide by the new power, add 1 to it, divide by the new power. If it's just an integral of a constant, you're just going to add on the variable, which is x in this case. So this is 1/3 x cubed minus 5/2 x squared plus 19x. So there's that part. Okay. Now this one, we're going to do a u substitution, but most of the time I don't when it's this case. Like, all right, u is going to be the bottom, and du is going to be just 1 dx. And that's exactly what I have. I have the bottom as a u, and the top I have that 1 dx. So this is minus 115 integral of 1 over u du. Normally I do all of that part in my head. Okay, so I get 1/3 x cubed minus 5/2 x squared plus 19x minus 115, the natural log of the absolute value of u, plus c, and our last step is don't leave it in u's, change it back to x's, which is x plus 5 plus c. Make sure you remember from algebra your long divisions. All right, one more and then we'll do some trig. All right, I want you to put a huge star in your notes by this one. I love this problem in some form of this problem, and you will definitely see it on your midterm, your final, on your quiz. This is one of my favorites. All right, so we've got this integral of 1 over x times the square root of the natural log of x. So I'm going to go ahead and take that radical out and write it to 1/2 power. Okay. And a lot of times people don't immediately know what to do on this one. I'm going to show you now so you know how to deal with it. But when you've got anything like where you see the 1 over the x and then you've got the natural log, whether it's just the natural log by itself or it's the natural log raised to some power, it's going to work like this every time. Okay. We want to go ahead and bring it up to the negative 1/2. All right. Remember, u substitution, let u be what's inside the parenthesis. All right, so then du would be, all right, well, derivative of the natural log of x is whatever's behind the ln on the bottom, derivative of that on the top. And that's exactly what I have. I have 1 over x dx. This is a straightforward u substitution problem. I'm going to call this u to the negative 1/2. And then I have everything I need for du. I have 1 over x dx. So I didn't have to multiply in any constants and cancel anything. I'm good. Okay. But now I do need to integrate this. So power rule it, add 1, but instead of writing plus 1, we're going to write plus 2 over 2 since it's a fraction. So my new exponent is a 1/2, and then dividing by 1/2 is the same as multiplying by 2. So I get 2u to the 1/2 plus c, or 2 times the natural log of x to the 1/2 plus c. It doesn't matter to me if you want to give me that answer or if you want to put it back in radical form. Either one is fine. All right, and then now, last thing we have are some trig, and you're going to memorize these. We've looked at trig integrals before, but we're going to add some more to it. All right, so when we've looked at the trig so far, you know, we've said, all right, well, whose derivative is this? Like, we had the integral of cosine, we're like, all right, whose derivative is cosine and sine? But when I get to something like this, whose derivative is cotangent? There's not a single trig word that its derivative is cotangent. So integral of cotangent and integral of tangent work the same way. You want to rewrite it, and cotangent is cosine over sine. Okay, and then it makes it pretty easy now to call u the bottom. And then du would be, all right, well, the derivative of sine is cosine. And that's exactly what I have. I have u on the bottom, and I have du. So if I switch it over, hold on, let's switch it over. All right, I'm going to call u on the bottom. So there's my, sorry, it's not working today. All right, so u on the bottom, and I like to put my 1 on the top. And then cosine x dx is exactly what I need for du. So this is natural log of the absolute value of u plus c, and you want to switch it back, natural log of the absolute value of sine x plus c. So tangent is going to work very, very similar, except for if you have the integral of tangent x, you're going to call the integral of sine over cosine where you let u be cosine now. You let u be cosine on the bottom, and then the derivative of cosine is negative sine. And so when you get ready and you replace it, that's the u. And you have almost everything you need. You need a negative, so you're going to throw that in there, and then there's your du. So you get negative natural log of the absolute value of u plus c, or negative natural log of the absolute value of cosine plus c. Okay, so that's how you integrate cotangent and tangent. I don't have those memorized a lot of times, and I'll just have to work it out like that really quick, but you can memorize this table, and you can see that the integral of cotangent, we just did that one, and then there's the integral of tangent. But you definitely, you can work those out if you forget them, but you definitely want to memorize the integral of secant and the integral of cosecant. Those are going to be something that you're required to know. The proofs are in the book if you want to go look at how to get those two, but we're going to use the rules on this next example. Okay, so those two star ones, make sure you have memorized. All right, so we've got to integrate secant 2x plus tangent 2x dx. I'm going to separate this out. We've got integral of secant 2x, and we've got the integral of tangent 2x. Okay, so anytime that angle is not a plano x, plano theta, you're going to do u substitution. I'm going to let u be 2x, so then du is 2 dx. So I know I'm going to have to have a 2 and cancel 1/2. So this is 1/2 times the integral of secant u du. All right, so you're going to have it memorized, okay, that the integral of secant u du is the natural log of the absolute value of secant u plus tangent u. Okay, so this is 1/2 as the natural log of the absolute value of secant u plus tangent u. And I'm not going to put on my plus c right now. I'm going to do it at the end, but switch those back from u's to x's. So secant 2x plus tangent 2x. Okay, and then over here, you can work it out. You can memorize the rule, but again, I know I've got to do that u substitution. So u is 2x, du is 2 dx, the same thing. I'm going to have to multiply the 2 and cancel with the 1/2. So this is plus 1/2 times the integral of tangent u du, and we just saw how to figure that out. Like, you could have rewritten it as sine 2x over cosine 2x, but we've got it memorized, and it's 1/2 times its negative natural log of the absolute value of cosine u. And now I'm going to throw my plus c on there. So if I multiply this, I get minus 1/2 times the natural log of the absolute value of cosine 2x plus c. All right, so make sure you have this whole table memorized and you know how to integrate all 6 basic trig functions. So especially memorize those 2 blue star ones, because those are the ones that you want to just have memorized. You could figure out tangent and cotangent. All right, and so we'll do one last example and be done with this section. All right, so when I'm looking at this one now, I have a definite integral, so I just won't put the plus c on the end. But I'm looking at this, and I'm just going to try u substitution first when I see that denominator. So I'm going to let u be theta minus sine theta, and let's just see if the top works out. So the derivative of theta is 1, and minus, and the derivative of sine theta is cosine theta. D theta, which is perfect, because if you look at the top, that's exactly what I have, 1 minus cosine theta. So I'm good. So I'm going to call the bottom, u. I'm going from 1 to 2. I'm going to go ahead and put my 1, and then the 1 minus cosine theta, d theta is du. Okay, so this is natural log of absolute value of u, and I want to integrate it from 1 to 2. So that's the natural log of the absolute value of theta minus sine theta from 1 to 2. So if I plug in, I get natural log. Remember, you plug in the top number first. I get 2 minus sine 2, and minus natural log of 1 minus sine 1. And if you plug that straight into your calculator, you know, we don't have sine 2 and sine 1, all those to figure out. If we plug it straight in, and I got 1.929. Okay. All right, so make sure you try your practice homework and your homework to turn in.